Hello, welcome to Chapter 3, Lecture 1 for Physics. In your book, you will want to open up to page 78, will be the first on your own problem that will work. And you'll need your notes. And we're going to add angles to our physics calculations this chapter. So, two-dimensional motion, 2D motion occurs in a plane, all right? So you can think of this whiteboard as a plane. It has an X and a Y axis. And arrows represent 2D vectors. The length of the arrow signifies the magnitude. So the longer the arrow, more magnitude. And the arrowhead points in the direction of travel. So you have a blank spot here. So let's just draw an example of some 2D vectors. So we just want to draw a coordinate plane in that little spot. And if you had me for pre-cal, you've seen this before, right? 0, 90, 180, 360 degrees. 270. And then back to 360, and you can keep going round and round and round in both directions. So let's say we have a vector that represents 3 miles. So displacement, let's say 3 miles at 50 degrees. Okay, so we would just give it a length like that. That stands for 3 in our case, and 50 degrees, it would be a little bit more than halfway in quadrant 1. And let's say we wanted to draw a vector that was just 2 miles and at 20 degrees. All right, well, it's going to be shorter than the 3-mile vector. So it's going to be, 2/3 of the length of the 3-mile vector because it's only 2 miles, and then 20 degrees is not a very sharp angle. Okay, so the first thing that we're going to do with vectors before we really get into the math is we're going to add and subtract vectors graphically. Now, if you're not happy with the explanation that I'm going to give you on how to do this after you watch the video, the book has a fantastically detailed explanation in blue example problems 3.1 and also 3.2. That's on page 76 and 77. So make sure you just read through those, but you might get it just from my explanation here. So with vector addition, we're going to move the back. All right. Hopefully your notes have been edited, but I had the tip before, but it's the back of the second vector. So back to the head, the arrowhead of the first vector. And the vector that completes the triangle is the sum, or what we call the resultant, and shown with a dashed line. That's for addition. Now for subtraction, we're going to take the vector being subtracted, pointed in the opposite direction. That makes it negative. And then we add the first vector to the second vector and complete the triangle. So I'm going to work 3.1 and 3.2 on your own on this blank space here for you. All right, so on your own 3.1, so this is on page 78. And I believe that I can go ahead and just draw the situation here, and we can use both. So we have vector A. We use this drawing for both problems. Vector A comes down into the third quadrant like that. And it's a little shorter than vector B. which is, roughly 70, 80 degrees. So vector B is the longer vector. And 3.1 says let's do A plus B. Okay, so I'm going to draw a new grid. And what you do is, if it's A plus B, we're going to leave A alone. That's the first one. So let's just leave the first one alone. We're going to add B. Now the way that you add B is you're going to take B and at the same angle slide it to the arrowhead. Slide the back of vector B to the arrowhead like this. Okay? So when you do that, you would end up, it's the same angle, you'd end up like that. It's the same length. Now it ends up a little bit lower because vector A started below the x-axis, right? Your resultant vector, which we're calling the sum, vector C, you go from the origin and you have just a dashed line there. So our sum, vector C, goes from the origin to the tip of vector B. Okay, so it's a little smudgy there. Let me get a different marker. There we go. But it ends up being, your resultant C ends up being like that. All right, 3.2, we're going to do B minus A. Okay, so we're still working off this one right here. Now we're not going to mess with vector B. It's the first one. So let's just draw it again. Now what we do with vector A is going down into the third quadrant here. We make it negative. We pointed it exactly the opposite way. So that is negative A. And then I'm going to take that and add, B minus A is the same as B plus negative A. So I'm going to add the two now. And we just slide negative A to the arrowhead, same angle, like that. And connect the two, and our resultant vector C, we draw with a dashed line. So if I drew vector C by itself, it would look something like this. Be longer and be up in the first quadrant at about that angle. All right, so that's how you add vectors graphically. Now let's go ahead and go through the math of this chapter. Let's go ahead and turn over to page 2 of your notes. All right, and this is going to be a review of things that we did in both Algebra 2 and in Pre-Cal. So going through the notes on page 2 left you a lot of empty space. First of all, we have the Pythagorean theorem. All right, called that Pythag in class. A squared plus B squared is equal to C squared. So we're usually solving for C, which is our hypotenuse, right? So C is equal to the square root, and all my markers are pooping out on me. Let's see here. Let's see if this will work. The square root of A squared plus B squared. All right, that marker's way too thick. All right, let me get another marker real quick. Okay, and where C is equal to the hypotenuse. Okay, next is the right triangle review. So if we have a right triangle like this, and we call the hypotenuse C, and we'll call A and B the two legs A and B. Do you remember the acronym? TOA. All right, sine, so sine opposite over hypotenuse. We usually use theta as our angle symbol, our generic angle symbol. So sine theta is opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. And then tangent theta is equal to opposite over adjacent. So tangent, opposite over adjacent. We don't have to use those inverse trig functions in this course, like cotangent or secant or cosecant, so that part is nice. And then theta, if you want to solve for theta, we take the inverse tangent. So that's tangent to the -1, just means inverse tangent of y over x. So you do have to memorize all of this stuff. All right, take a minute while I clean the board. Okay, further on down, we're at the middle of page 2, x and y components of 2D vectors. So on the left side of your paper, let's draw a coordinate plane. And let's draw vector A. All right, that's vector A. We can cut that vector A into its x components. I'll go ahead and make it blue. We'll call that A sub x. And its y component, A sub y, with theta as our angle. Okay, so the magnitude of vector A is just the Pythagorean theorem, the square root of A sub x all squared plus A sub y all squared. If you want to get the direction angle, that's going to be inverse tangent of A sub y over A sub x. Now we know that with SOHCAHTOA, sine theta is going to be A sub y, the opposite of theta, over the hypotenuse A. So solving for A sub y, if you want to get the y component, you bring that A out front, so it's A sine theta. Just try to remember that y goes with sine. Y goes with sine. And then cosine theta is equal to A sub x over A. So A sub x is going to be A cosine theta. Cosine goes with x. All right, so again, you're going to use all of these a lot. Okay, finally, with using inverse tangent, the calculator will give us, remember this is 0, 90, 180. The calculator will give us answers that in a way that we don't want to report. It'll give us negative answers. And this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if you take the inverse tangent and you end up in quadrant 1, we do nothing to our calculator answer. All right, again, this is when you're dealing with inverse tangent. If we end up in quadrant 2 or quadrant 3, we're going to add 180 degrees to our calculator answer. So in this class, we're only going to use degrees, no radians, which you might remember from pre-cal. And in quadrant 4, so in case you have a positive x but a negative y, quadrant 4, we're going to add 360 degrees to our answer. So you do have to memorize these, and we did those in pre-cal last year as well. All right, great. So pause the video if you need to. Let me clean the board, and we'll work some problems involving all of the notes that we just took on page 2. Okay, so page 3 of your notes, flip over there. We're going to work 3 problems, and in this lecture we'll be finished. We're on your own 3.5, excuse me, 3.3. We're going through 3.5. And this 3.3, if you'll flip in your book, we are on page 85. Look at us go, already on page 85. So 3.3 says the velocity vector of a car has an x component of 23 meters a second and a y component of 11 meters a second. What's the magnitude and direction of the velocity vector? All right, so to get the magnitude, we'll call this vector v, all right, the velocity vector. It's going to be the square root of the x component squared plus the y component squared. So that's going to be the square root of 23 squared plus 11 squared. All right, and that'll give you 25.5 meters per second. Don't forget the units, even though I didn't use those I didn't put those underneath the radical. So 25.5 meters a second. And then the direction angle will be the inverse tangent of v sub y over v sub x. So that's going to be inverse tangent of 11 over 23. Okay, so let's put that in your calculator. Okay, so we're going to find the tangent, inverse tangent button. So hit the second button and then tangent. Do 11 divided by 23. And you'll get, make sure that your calculator's in degrees. If you've forgotten how to change that, go to mode. That's 25.56 degrees. Now, do we have to change anything? What quadrant are we in? Well, 11 and 23, both positive. We're in quadrant 1, so that's a do-nothing situation. So our direction angle is indeed 25.56 degrees. All right, 3.4 says a person walks due west to the left on a Cartesian coordinate plane for 1.1 miles and then walks due south down on a Cartesian coordinate plane for 2 miles. What's the magnitude and direction of her displacement vector? All right, so this lady is walking 1.1 miles to the left and then down 2 miles. So we want to know what's the magnitude and direction of the displacement vector. We can call that anything we want. We'll just call it vector A. Okay, so since it's to the left and down, both are negative. So A is going to be the magnitude of A, the square root of negative 1.1 squared plus negative 2 squared. Now make sure you put those negative numbers in parentheses, all right, because that can get you. You shouldn't have a negative number under the radical. Okay, so it would be, the way I like to do this is I would just do left parenthesis negative 1.1 squared plus left parenthesis negative 2 squared. All right, hit enter and raise that number to the 0.5 power. That way I don't have to find the radical, on here on the calculator. That's 2.28. So the magnitude is 2.28, and make sure you put the unit of miles. So the direction, we are going to have to be careful here. It's going to be inverse tangent of y over x. Well, y would be negative 2, x would be negative 1.1. Now, what quadrant are we in there? Okay, we're in quadrant 3. So we're going to have to change this answer. All right, so in the calculator, we're going to find inverse tangent. We have negative 2 divided by negative 1.1. Oops. There we go. That's 61.2 degrees, but that's not in quadrant 3. Okay, so we have to do what? We have to add 180. One of the most common mistakes. So that's 241.2 degrees. All right, so if you don't make one of these simple type errors, wow, this is just some easy stuff that you've done many times before. In fact, if you had me for Algebra 2, we did some of these exact problems late in the year because I was hoping some of those folks would sign up for physics. And of course, we did cover this in pre-cal. At least this type of math. All right, last example problem of the day. 3.5 on page 86. So it says an acceleration vector has a magnitude of 55 meters a second squared, angle of 300 degrees. What are its x and y components? Well, we have to remember cosine goes with x and sine goes with y. So we know that our magnitude is 55 meters per second squared. And our angle is 300 degrees. So a sub x is going to be 55 cosine 300 degrees. All right, the magnitude times the cosine of theta. All right, if you plug that into your calculator, you get 27.5 meters per second squared. All right, so that's your x component. And then your y component for this acceleration is going to be 55 times the sine of 300 degrees. All right, plug that in your calculator. If your calculator is your friend, you'll have negative 47.6 meters per second squared. All right, that does it for our first of 2 lectures in Chapter 3. Your homework, you can do review questions, page 102, 1 through 7, and practice problems, page 104. Let's go ahead and just do 1 through 5. So there you go. I hope you enjoy doing this homework. Not too bad. I'll talk to you next video.